Alright, what's up guys? In this video, we're going to put some complex analysis. Going to be talking about how to find conjugates and Hermitian conjugates. So we're given this matrix here. We can call it matrix A. And it's basically a 2x3 because we have 2 rows and 3 columns. And they want us to find the complex conjugate, and they want us to find the Hermitian conjugate. Okay, so we can start the first part, which is to find the complex conjugate. So really all we have to do is to find the complex conjugate for every entry in the matrix, basically. And we'll denote the complex conjugate of this matrix as A star, and then we'll move on to finding the Hermitian conjugate. Okay, so given our A here, or our given matrix, we'll take the complex conjugate, and again we'll denote it A star. I'm just going to take the conjugate, or take the complex conjugate of every entry in that matrix. Okay, so that's just going to be 1, 2, complex conjugate of 3i is minus 3i. Complex conjugate of 1 plus 3i is 1 minus 3i. And then we'll just have 1 and 0. So that's the complex conjugate right there, which we denoted A star of matrix A. And now part B is to find the Hermitian conjugate. So that's what we're looking for now. So for the Hermitian conjugate, all we have to do for the Hermitian conjugate is transpose our complex conjugate matrix. So if you look here, we got A star is equal to our matrix here, which is complex conjugate of A. So all we have to do is transpose the matrix. Now remember how you transpose a matrix. Hopefully you remember this from linear algebra. You swap the rows, you change the rows into columns, basically. And so to denote the Hermitian conjugate, we'll just use A raised to the T, because we know we basically, when we're trying to transpose a matrix, we put the T at top to denote that we've done the transposition. And so we'll denote that A raised to the T. And so if we transpose this matrix, I'm going to make it a little bigger. If we transpose it, that means that we'll have 1, 2, negative 3i, 1 minus 3i, and then we'll still have 1, and we'll have 0. And this would be here the Hermitian conjugate of A, and this would be the complex conjugate of matrix A. So for our final answer, all you have to do is transpose the matrix, swap the rows with columns, and that'll give you the Hermitian conjugate. So A star. And notice how the matrix is of same order. 1 minus 3i, 1 and 0. That's the complex conjugate. And this is our Hermitian conjugate. So we got 1, 2, negative 3i, or 1 minus 3i, 1 and 0. And that's your answer. Alright, so that's pretty much how you do it. So let me know if you have any questions about it. But other than that, that's going to be it. And I'll see y'all next time.